to show you how to make it a little easier to hone gouges like this, hook knives like this, hopefully eventually a draw knife like this, and small irons like this that you see inside this spoke shave, in this case using the Veritas small knife holder. So this is a Vicmark VL300 lathe. It has a 24-inch swing. So what I have at present, I have 3 pieces of MDF glued together, secured to a faceplate. This is a faceplate I made. As you can see, that's welded. I'm not a professional welder, so it might not be the prettiest looking weld, but it does the job. Have it through bolted too, just for added security to make sure it doesn't move. Just putting the honing compound on the wheel. So initially I had the idea that I would do a lot of my honing here, but I find it easier right here because I can sight right down the flat and see where I'm making contact. Versus here, I find it easier to roll the edge of your tool over. So this is much easier to work with on the side. So that will be my primary honing surface. So I actually shot this video a couple of weeks ago, and since then I've had an epiphany on how to improve the process of making it, something to really make it easier to make. So stick around to the end and I'll show you that little trick. So today I'm going to make a slight change to the new honing wheel. I'm going to create a cavity inside. The reason for the cavity is it will allow me to hone. This is a spoke shave. It will allow me to hone a tool like this for things to, and also for draw knives. So the handles, or in this case, the securing screw or machine screw, can go into the recess. So this one, it's already glued up, is 3 pieces of MDF. I'll show you how I got to this point, and then I will show you how I'm going to take this one and get it to this point. Hopefully an improved version. I am going to use a factory produced faceplate rather than this one that I made, because the shoulder of the handmade faceplate does not contact the shoulder of the spindle consistently all the way across. Therefore, there's a little bit of wobble in this faceplate. As we've already said, this is going to be made up of 4 pieces. We want the outside 2 pieces to have a recess, and we need to cut those before we glue everything up. Because MDF is so abrasive, it wears tools down, we want to minimize how much turning we have to do. We're drawing lines corner to corner so we can establish our center point and therefore draw circles off that center point, and I can cut the center area out. The outside raised section should be small enough such that we can sharpen the smallest tool that we want to straddle that area with. The reason that we're using 2 solid pieces behind this is for rigidity. We do not want deflection when we press our sharpening tools against it. We're going to start by drilling a hole. Keep it just inside the line. That way, if we get any blowout when drilling the hole, it does not end up in the finished product when we cut it out with the jigsaw. So now we have this board straddling my my bench vise. Just gonna use a jigsaw and cut the circle in the middle. So now this is my faceplate that I'm going to use. This is the faceplate that came with my Vic mark. I took some dividers, put a little mark there, came back to the other side, put an opposing mark. That met up at the center point. So now I'm going to take a center punch and mark that. Make my dimples a little bigger. Here we are at the drill press. Let's go ahead and got it clamped into my vise. These two pieces of wood just so that I'm not drilling into the vise. First hole's already lined up, and that's drilling nice and easy. So what I should have done, but I forgot, before I cut this round, I should have drawn X's across my corners. We still have evidence of where the flats were. I just measured to find the center. It's probably not going to be dead on, but it should be close enough. Set up my compass to be the same size as my faceplate. Just going to quickly measure and just kind of see, make sure that we're centered. Again, this doesn't have to be perfect, but closer is better. Goes a little faster. The holes that I didn't drill, the factory holes, are here on the 1/4 inch. I'm going to through bolt through the ones I did drill. Those are 1/4 inch. So putting the screws in the factory holes. Tighten them up, but don't strip them. Probably should use new screws, but these are used. Do not use drywall screws. Drywall screws are not good. These are, you can use deck screws, construction screws. These are square drive screws that Woodcraft sells. I'm going to go ahead and drill 1/4 inch holes. I'm going to go ahead and countersink those holes that I drilled. This is my nut that I'm sticking on the back side. So just going to put a little mark here with my marker. We'll just cut the same amount off each screw. And my porter band, it's mounted to a piece of aluminum and screwed to some plywood for a platform. I'm going to go ahead and cut the screw off. Scrap piece of wood with a notch cut on it creates a nice little carriage for cutting these bolts, so you can cut them square to the table. A porter band is probably one of the handiest things to use for cutting. It doesn't leave much of a burr, so you can get the nut on there. You can use a hacksaw, you can use a grinder, angle grinder. I suppose there's probably more methods out there too. A Dremel would work. Go ahead and stick these lock nuts on there. And basically once we've mounted this on, we don't have to worry about anything pulling out. Won't be running at high RPM anyhow, but figure what the heck. So what we're going to use is a carbide tip turning tool. This is not made by Easy Wood Turning, it's just a cheap Amazon. It does, however, do a good, it does the job just fine. If you use any type of like bowl gouge or scraper, it will dull it very quickly. So, needs to be carbide. Using my finger against the rest there to be a gauge.
Slight crown, let's see if I can take that out.
Before we get too far into this video, I want to give it a little warning of precaution. Honing or power honing can be dangerous. I have yet to have it grab a tool and pull it out of my hand, but that is potentially possible. We are honing tools that are extremely sharp, especially if you're going to use, this is a spoke shave iron held with a Veritas small knife holder. If you're going to use this honing device to hone a tool like this, there is potential that you could kind of pinch it between those two surfaces, or if you rotate it this way and pinched top and bottom, that it could pull out of your hand, and now you have something that is somewhat of a projectile. So I don't know about projectile, but it could get thrown, and something thrown that is, even if you're moving at very slow speeds, could stick into you or someone else. So a little word of caution there. I have not thoroughly tested this. I have used this a lot on straight knives. I am using it at extremely slow speeds. The tool needs to be running backwards if you're holding the knife edge up. If you want to hold the knife edge down, this is not how I do it, but then you want it to run the other direction. If you run your lathe into the sharp edge, it will dig in and you will probably lose control of the tool, almost surely. So just a warning and precaution before you get going on this. I don't want anybody to get hurt. I'm going to go ahead and apply some honing compound. This is Veritas honing compound. I just got this, so I don't really know how well it performs. I'm running my lathe in reverse and very slow. I'm going to start with sharpening the knife that I find the most difficult to sharpen, or to hone, that is. You can see the metal on the wheel. Eventually I want to make a 90-degree tool rest. So there's the hook knife. This is the reason why I created this cavity, so if I wanted to sharpen a draw knife on here, I could do that. The draw knife. This is a spoke shave. I took the iron out, put it into the small knife holder made by Veritas. And if you just want to sharpen a knife, you can sharpen a knife as well. And for honing the other side, I just come around the other side of the lathe and hone the opposite side. I also flattened the back side of this, or trued up the back side, so I wouldn't necessarily have to walk around the back side. I just have to put some more honing compound on the back if I'd like to go that route. So as you see, I've been using this for a while. You can see right here, and maybe here and here, where it's a little more worn than in other spots. I don't know if you're going to be able to pick this up, but we're going to try. It's not perfectly flat. It was about it. There, you can kind of see it rocking right there off that high spot. So I am going to level that off. I have a technique that I believe will make it almost perfectly straight. Not level, straight. The first thing I need to do is take off all the honing compound, because that is going to dull whatever tool I use to straighten this very fast. So I am going to use a tool that I can resharpen, which is, for me, a bowl gouge, and I'm going to use it in a scraping fashion. All the evidence of the honing compound is gone. Now it's time to make this flat. Switch my tool rest out to a factory purchase tool rest. I've actually turned it around because the back side of this is straighter, or I don't have, this is beveled and this is not, is more accurate. We're going to clamp this right here, and it is going to ride along that rest. So over here, if I tilt the tool at all, and obviously that'll affect how flat we are, but this would affect it more, it could ride up or ride down, and therefore affecting the depth, whereas here, it does not do that. Just gonna take a file and knock off any edges. Just use it flat on the rest. Nothing to cause a hiccup. Just gonna put that on there, make sure it rides on there nicely, and it does. So we're good. What we're gonna use to clamp onto our carbide turning tool is this device right here. All it is a piece of steel, has two aligned holes. One side is tapped for this 1/2" bolt, and that is going to clamp onto our turning tool. You don't have to have this. You can make do with even two pieces of wood that have an exactly same size hole and just through bolt it. But this is going to be easier for me to use, so I'm going to use this since I have it. What this is something I made, but I believe these are commercially sold, is this clamps onto a knife and keeps you from grinding beyond your start point. So if you want to buy one, you can probably look for like Jansen Knife Supply or something. But you can make something that would do exactly what this is doing. It doesn't have to be made out of steel. The first thing we want to do is make the rest parallel to the MDF. And to do that, I'm going to use a combination square. So I have intentionally positioned my tool rest so it is closer here than it is over here. So I'm going to take the combination square and make it tight right there, and you'll see a small gap there. The banjo is tightened down firmly to the ways. The tool rest is not all that firmly tightened, so now I'm just going to the end result is this will be squared or parallel to this. That's all that matters. We want this flat. We want it mostly perpendicular here. We're not trying to create something that kicks in or kicks out. Tighten that down so it can't move. So now we have this clamping device clamped to the carbide turning tool. Put it up against the rest, and we have less than a 1/16 of an inch gap between the steel of the clamp and the rest here, because our carbide cutter is touching the wood. So then what we're going to do is we're going to turn the lathe on. We're going to start right here, and we're going to work our way all the way across. And we're going to do that a few times. And go ahead and take a wrench, snug up that clamping device. Don't overdo it. Depending on how thick your steel is here, you can strip. You do not want to strip that, obviously. So you want to keep this, you're going to tilt it in. If you ever use a scraper, that's what this tool is. This is a carbide scraper. You see that little dot there? That's just me rotating this to a fresh, sharp edge. This was the sharpest edge. MDF is very abrasive and dulls tools quickly, so you want to use carbide like I've already said. And I'm just going to work this thing across. I'm going to move my hand and get out to the end here. Probably took more off there than I needed to. I think we have it. I cannot see any high points there. It doesn't rock at all. You probably could not see this in the video, but tilting this changed our depth. We need it tilted down, as in this lower than your handle. So something to be aware of there. But that seemed to work perfectly. And you know, again, you probably could not see this. I locked my arms into my body and just rolled my body backward, so I was not moving my hands up and down. And that is our little tip of the day. I'm going to soften these corners right here. I want to make sure that we don't have any sharp edges. You know, if you run your hand on there, you don't want to cut yourself. Wood can cut you, believe it or not. I'm going to go ahead and do the other side and this surface. I don't believe we really need to show that on the video. Alright guys, just a quick wrap up here. Turn this light off and see if we can eliminate some of that glare. Look right there along that straight edge. You will see no gaps. That's what we want. I did go ahead and do the same thing here. Straighten that up. And here too. Both of those using the same method. Probably use a little more light over here, but you can kind of see what's going on. Oh, I got too far in. Right there. No gaps. I was only able to get to a point, which is about there, before I ran out of space at my lathe with my turning tool. But this is the area, really the only, you know, last couple of inches is the only thing I'm going to be honing on. Again, knock your sharp edges off. There and here. And also in here. And we're all set to apply some honing compound. Guys, that's it for now. I hope you enjoyed the video. If you liked it, please like the video. Please share it. And I hope to see you again. Take care. Have a good one.